they're dismissing to class, let me just say a few words of thank you. What a privilege it has been to be with you all week long. Thanks to all of you who took us into your home, took me out to eat. You folks know how to feed a fellow, I can tell you that. I think it's a 5-pound meeting. It's been a special privilege to be with Bruce. Sure have enjoyed it. I recommend your taxi service, your kindness and graciousness, and just been a joy to get to be with you and learn who you are better. And I especially have enjoyed being with Sammy. If you don't know, we go way back. Way back, Sammy, many years. He's old, and so am I. But we sure have some special memories, don't we, Sam? It's been a great privilege to be together again. We were in school together, and we played basketball together, and we did lots of other things together that were enjoyable and that were, I believe, in accord with God's will while we were having fun. And so it's been a real pleasure, Sam. And for many of you others, so glad to get to know you. You're blessed here at this church. It's clear that you're growing, you're enthusiastic. Thank you for the many words of encouragement and acceptance and understanding and willingness to learn. You've been a pretty good chemistry class, I can tell you that. Most of you haven't slept. And that's saying something because it's pretty heavy material, but it's a privilege. And thank you for the opportunity to be here. I have learned long since that 3 or 4 nights of this is enough for most congregations. And so tonight I want to turn our attention to the macroscopic world. And I think it will be especially a privilege for you to do that with me tonight. I want to say to the fellows that are in charge in the back, thank you so much for your work as well. This kind of a lesson can't be done without visual aids. And if it doesn't work, you're in big trouble. So I appreciate them so much. And tonight, I forgot to tell you guys in the back, I'm going to need help with lights later. So be ready, because there are going to be times where we want the lights off so you can see better. All right. Is it reasonable to believe in God in this scientific age? We've talked about that as our theme all during this particular part of our series. And the answer for many people is no, it is not. The answer for me is it's more reasonable than it's ever been for us to believe in God. Science, in what it's discovered, has opened the doors for more belief, not less. So it seems to me. And our passage from Scripture that we've used as our theme is Romans 1, which you just had read to you again. So we'll not explain that again tonight, except to say that in that passage, the Bible teaches that you can learn about God without the Bible. I want to say that one more time. The Bible teaches that you can learn about God without the Bible. You can learn about Him by the things that are made. That's the natural world. And the argument, as you see here, is the argument from design. If you see design and it's clear that it is design, then it requires a designer, and in this instance, a designer that is beyond nature. Nature did not do this. And the evidence of the natural world testifies to that loudly and clearly. So, as I said before, we're not going to use this book in this particular series. We're going to use God's other book, which is the book of the natural world, which leads me to the lesson tonight. Here's one of the most famous pictures ever made. The title of this picture is Earthrise. Earthrise. Some of you were alive when this picture was taken. I was. That, of course, is Earth. Anybody know what this is? That's the surface of the moon. So I'm going to be reading now a little bit to you from a book called The Privileged Planet. I highly recommend this text to you. Fascinating. A little bit heavy when it comes to the science, but you can skip over some of those and still get the main point. On Christmas Eve, 1968, The Apollo 8 astronauts, Frank Borman, James Lovell, and William Anders, became the first human beings to see the far side of the moon. The moment was as historic as it was perilous. They had been wrested from Earth's gravity and hurled into space by the massive, barely tested Saturn V rocket. Although one of their primary tasks was to take pictures of the moon in search of future landing sites, the first lunar landing would take place just 7 months later, in 1969. Make me feel better and raise your hand if you were alive then. Okay. Many associate their mission with a different photograph, commonly called Earthwise. And I'm taking a little aside here, just for your interest. I don't have time to tell you the story. In my office back at Florida College is the original print of that picture. The original print from 1968. So if you want to hear that story, ask me later. It's very special to me. Emerging from the moon's far side during their fourth orbit, the astronauts were suddenly transfixed by their vision of Earth, a delicate, gleaming swirl of blue and white, contrasting with the monochromatic, barren lunar horizon. Earth had never appeared so small to human eyes, and yet it was never more the center of attention. To mark the event's significance and its occurrence on Christmas Eve, the crew had decided, after much deliberation, to read the opening words of Genesis. In the beginning, God created the heavens and the earth. The reading and the reverent silence that followed went out over a live telecast to an estimated 1 billion viewers, the largest single audience in television history. Do you think astronauts would be allowed to read that passage today? I don't think so. But it was a dramatic event. And I can tell you the reaction of James Lovell and Frank Borman was to increase their faith as they looked at this, and they thought, what an amazing thing God has done. William Anders, on the other hand, said the following, and I'm going to quote from William Anders. This photograph really undercut my religious beliefs. The idea that things rotate around the Pope and up there is some big supercomputer wondering whether Billy was a good boy yesterday, it doesn't make any sense. I became a big buddy of Richard Dawkins, said William Anders. And among other things, he said, you really believe there's some God out here? I don't see any evidence of God out here. And he lost his faith. The point of that is this, ladies and gentlemen. Those three men were looking at the same evidence, and they drew completely different conclusions. So there's more to this than just the evidence, isn't there? There are all kinds of factors that play into it. I wish it were just the solidity of the evidence that could convince someone. But there are other factors involved. In September of 1997, NASA launched Voyager 1 from Cape Canaveral. 13 years later, and you can see its path here from Earth out through all the planetary orbits and then out of our solar system and continuing on. That spacecraft, ladies and gentlemen, is still traveling, and we're still getting signals from it in 2019. It's the longest lasting spacecraft ever. In 1990, it was decided under the urging of Carl Sagan for it to turn back its cameras and take a picture of Earth. And it did. So guys, are you ready with lights? That is not in the picture. That's superimposed, but it's pointing at something. You see that little dot right there in this beam? That little dot, ladies and gentlemen, is a picture of Earth from 4 billion miles away. And Carl Sagan used that occasion to have some things to say at Columbia University, and he also wrote a book called The Pale Blue Dot. I'm going to let you look at that for just a second, and then I need a little light up here so I can read what I need to read. Thank you. Here's Carl Sagan. Because of the reflection of sunlight, Earth seems to be sitting in a beam of light, as if there were some special significance to this small world. But it's just an accident of geometry and optics. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale blue light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all of this vastness, there is no hint that help will come from elsewhere to save us from ourselves. And so Carl Sagan's perspective of the universe is that we're just a little old dot in the midst of a massive universe of nothingness. And do you seriously think there's some God that cares anything about you? Absolutely not. Don't you be waiting for some God to come and save you. And I can assure you in the 1960s, which is when this all was first taking place, this came much later, but Sagan was around for a long time. I was at Harvard in the 60s. He was at Princeton. And if you sat in classes with these gentlemen, you would be told things like I was told. If you're a believer in God, you better get over it, because we have long since discovered enough about this world to know there is no God, and you're fooling yourself. And that refrain continues to the present time on the part of many. And pictures like that, they use to full effect. Have you ever heard of the Copernican Principle? If you've studied anything about science history, you know that Copernicus was a character in the Middle Ages who studied the heavens very carefully. It is Copernicus that is credited with discovering that the earth is not the center of the universe. That the earth is not sitting still in the middle of the universe with everything else revolving around it. You surely are aware that the common perception of many from the Middle Ages back was that the earth stayed still and steadfast and other things revolved around it. And that God's attention was focused on this centerpiece of the universe. When Copernicus and Johann Kepler and Tycho Brahe and numerous other astronomers of the Middle and early Renaissance age began to find out that the evidence doesn't support that, it was very challenging to people's faith. And there developed over time a principle called the Copernican Principle, otherwise called the principle of mediocrity, which basically declared that the earth and its surroundings were pretty average and normal, mediocre if you like, and certainly nothing special, and that human beings had been displaced from the center of the cosmos, and that it demonstrated life and the conditions required for it were unremarkable and certainly not planned, so they said. And scientists who believed that there's nothing but nature, as Sagan famously said in his Cosmos series, the cosmos, all there is, all there ever was, or all there ever will be. The naturalists took over dominance in the scientific world. And the Copernican Principle ruled the day. The result of that, philosophically, that principle of mediocrity became the philosophy of materialism and positivism. Humans were displaced. Our solar system became an ordinary, normal, mediocre place. And the viewpoint arose, there surely are many of these, because at the same time arose the notion that life, after all, evolved by natural causes here on earth. Surely that happened somewhere else as well. And so arose the notion that there may be lots of other civilizations. So when I was at Harvard University and taking a course in astronomy, a required reading was Intelligent Life in the Universe by Carl Sagan and I.S. Shklovsky, Russian co-author. And this book is all about how we are reasonably certain there are lots of intelligent civilizations out there, how we might go about discovering that, and what things we might expect, and what signals maybe we should send to try to communicate with some of these civilizations. Frank Drake lived in the 1960s and proposed this first effort at trying to figure out how many civilizations might there be. I don't have time to explain all this to you, but I'll show you briefly. N is supposed to be the number of communicating civilizations in our galaxy, in the Milky Way galaxy, right now. Well, he said there are lots of factors that would affect that. Just look at some of these. NS is the number of stars in the galaxy, which is about 200 billion. FS is the fraction of stars suitable for life. Folks, that's a pure guess. The fraction of suitable stars with planets, again, that's a pure guess. The average number of habitable planets or moons per solar system. Again, all of these down here are guesses. And even at the factors that affect how much they affect, nobody knew. But with all of that wonderful science, down here at the bottom, the number of possible communicating civilizations is somewhere between 0.000000005 and 750,000. Somewhere between almost 0 and 750,000 is how many we might expect. Close enough for government work, I guess. But it was a first effort to try to figure out how many communicating civilizations might exist out there. And Frank Drake gained quite a notoriety. And of course, he's here in this book and lots of other places. At least it was a beginning effort. Coming out of that, Carl Sagan and lots of others made estimates. And Carl's estimate later on in the 1960s and early 70s was there might be as many as 1 million communicating civilizations in our Milky Way galaxy alone. So there was great motivation to start looking. And I've told you already this week that SETI is still working at finding evidence of those civilizations. That started in the 1960s. And it was because of this rampant view that there's lots of other civilizations. Evolution took place rather easily in lots of places. How many have seen that movie, Contact? Quite a few. How many have read the book? Nobody. That is so typical of our age. The book's better. Guess who wrote Contact? Carl Sagan. And let's see, I think I have the copyright date in here. Carl Sagan wrote that book in 1985. After telling us in the 1960s and early 70s there were probably 1 million civilizations in our own galaxy, much less everywhere else. And by 1985, how many had we found, ladies and gentlemen? And what evidence had we raised from SETI for an intelligent civilization somewhere else? Exactly nothing. How about in 2019? There is zero evidence anybody has collected of any intelligent civilization anywhere but here. Don't believe about the little green men and the supposed spaceships that have been sent here. I made it a special point of my business while I was at Harvard to do a special study on UFOs, unidentified foreign objects. And I'll tell you, in my study, I found every one of them to have a perfectly reasonable explanation, or they were made by people who didn't have it all upstairs. There isn't any evidence, ladies and gentlemen, some spacemen have come and visited Earth. So in 1985, Carl Sagan decided he'd write a book where it did happen. He called it Contact. I'm going to tell you a little bit about that tonight because it illustrates a point I want to make. But I'm going to say it now and I'll try to remind you later. This is science fiction. It's not reality. And if you saw the movie or you read the book, you know that the purpose of the book was to say they made a contact with somebody in one of these civilizations. In fact, the little title there says, "A Message from Deep Space, Who Will Be the First to Go? A Journey to the Heart of the Universe." See, in this book, they not only get the signal, but they end up going to the middle of the Milky Way galaxy and finding these people. It's a nice story, but if I may use common parlance, there ain't no truth in it. So how did they decide there was somebody out there? They got a signal on the radio telescope. And there it is. That's a little hard to see, so let me blow it up for you. So I'm going to let you study that a little bit and see, do you see any intelligence in that? Well, you would if you knew what it was. So let me tell you. These little ones here stand for bleeps on a radio telescope. The zeros stand for pauses. So let me help you here. And when you identify what's going on, will you raise your hand for me? And by the way, if you already saw this or you read the book, you can't play. All right, so notice there are 2 bleeps and a pause. Then there are 3 bleeps and a pause. Then there are, how many? 5 bleeps and a pause. Then there are 7 bleeps and a pause. Then there are 11 bleeps and a pause. Anybody want to name the next one? 13 bleeps and a pause. Anybody name the next one? No, not 15. 17 is the next one. Have you figured it out yet, class? Those are the prime numbers. So help me, who said prime numbers? What is a prime number? I'm really putting him on the spot now. It's a number divisible by nothing. You mean zero? You can't divide anything by zero. It's divisible by 1 only and itself. Did I lose you, class? A prime number can be divided only by 1 and itself. So, you asked me about 15. Is 15 a prime number? Why not? Because it's divisible by 1, 3, 5, and 15. That's not a prime number. How about 17? 17 is divisible by 1 and 17. That's all. That's a prime number. Is everybody with me? Let's keep going. What's the next one? Anybody know? 19. That's right. So there's exactly 19 bleeps there. And then a pause. So what you see, class, is tied up in this message is the first 25 prime numbers in a row. You know what the 25th prime number is? That's not something you carry around in your head, is it? Starting right there with that 0, and if you counted all those ones right there, that's the number 101, which is the 25th prime number. So, please listen to me closely. In the book Contact, they had their radio telescopes trained in a particular place in the Varga constellation over a period of time, and they observed, after they took out the noise, this signal. When they understood it, they found out that tied up in that signal were the first 25 prime numbers in a row. Can I tell you that in his book, Carl Sagan wrote in the 1960s, he said one of the ways we'll know there's an intelligent civilization out there is if we got a signal that had the first 25 prime numbers in it. So he put it in his book. Has anybody gotten such a signal from outer space? No, they have not. But what if they did, class? What if they did? I would tell you what I would think. If it were real, now you can fake stuff, but I'm telling you, if it could be demonstrated, you got such a signal, that is powerful evidence that somebody out there is intelligent. Nature doesn't bleep out radio signals with the first 25 prime numbers in a row. Would you agree? So I have no objection to looking. We just haven't found anything. But they did in Contact. So I want to take a little bit of time with you right now and explain to you why it is one would conclude that's from an intelligent source. In other words, that was designed. Are you listening to me? This is the whole argument I'm making. Can you decide if something was designed or not? I say yes. It'll have features of intelligence. So how about this one? Well, let me take you to a little book, which I'd highly recommend to you. It's called The Design Inference by William Dembski. Dembski's a philosopher and a mathematician. Brilliant man. He argues in this book that you can infer something was designed if you have certain characteristics mathematically. I love that because math is the queen of the sciences. And if you can do something mathematically, you're getting as close to thinking God's thoughts after him as you'll ever get. He says you can analyze design mathematically. So I'm going to give you a brief math lesson, class. Stick with me. Here's what Dembski says. Any event or object has only three possibilities. It either had to occur, that is, it was inevitable, or it was an accident or pure chance, or it was design. He argues there are no other answers to that question. So I'm going to leave that for you to think about. Can you think of another way to answer it? Some kind of event or something. Let's just take this signal that I just told you about. If that really happened, there it is. How'd it get there? It either was inevitable, or it acted by chance, or it was design. That's what he argues. So how do you decide that? Here's what he said. You need to put it through this funnel, this test. He said you need to ask three questions. The first question is this thing contingent? What that means is, could it have happened some other way? Or is this the only way it could have happened? Well, the signal I just put up there. Couldn't radio messages have bleeped out in lots of different ways? Didn't have to happen that way. It's certainly contingent. So it wasn't inevitable, which means the answer to the first question is yes. It's contingent. There was many ways that could have happened. That's the first question. Second question is it complex enough that it could not have happened just by chance? Well, I ask you, class, 25 prime numbers in a row bleeped out by a radio telescope. You think that happened by chance, if it really happened? The chances of that happening are so infinitesimally small, they're essentially zero. Now, this is the hardest question in his funnel of questions. And most of this book talks about how you decide whether it could have been done by chance or not. And that's some heavy mathematics, because it's probabilities. But it can be done. And he would tell you the answer to the question of the 25 prime numbers in a row is absolutely yes, it's too complex to be done by chance. Then he says you need to ask one more question before you can be reasonably certain that it happened by design. And that is, was the information specified? And here's what he means by that. Could you have described what you wanted to get and arrive at it some other way so that it's specified information? For example, class, if I said to you, I want you to generate for me the first 25 prime numbers, could you do it? Forget you ever saw that. Could you generate the first 25 prime numbers? Yes, you could, because you're brilliant. So help me. Is 2 a prime number? Yes, because it's only divisible by 2 and 1, right? Is 3 a prime number? Yes. 4? No. 5? Yes. 6? No. 7? Yes. 8? No. 9? No. 10? No. 11? Yes. You're really good. Could we keep going all the way to 101? Yeah, it'd probably get a little harder. But you could generate the first 25 prime numbers without knowing anything else except how you define them, right? It's specified. That's why Sagan said in his book, we're going to specify ahead of time things to look for that would indicate intelligence. So Dembski says you can determine that's specified, and if the answer to that is yes, and it's part of the thing you're observing, then you can be 99.9% certain it was designed. Mathematically. I like that as an old math teacher. So, what about that signal? Was that designed or wasn't it? I can tell you in the movie, they said it was designed because it was contingent, it was complex, and it was specified in advance. So everybody concluded this was an intelligent source. So much so, they started spending money and figuring out how they're going to get somebody out there to go find them. And may I say to you, ladies and gentlemen, I'm fine with that process of thinking. My only argument is, why don't you allow us to do that in biology when we look inside a cell? There's all kinds of signs of intelligence there. In fact, isn't there a language that we've learned to decode and read inside the cell? We call it the genetic code. So why would we not conclude that was designed? That was Monday night's talk, right? Well, I really like that combination of things. I'll remind you for the last time, contact is science fiction. But the reasoning isn't science fiction. It's perfectly good science and mathematics. It just hadn't happened yet, and maybe never will. Which is part of my discussion tonight, class, so it's a perfect lead-in. I hope you're with me. Rare Earth was written in 2004 by Peter Ward and Donald Brownlee. They are thoroughgoing evolutionists. They do not believe in God. But they wrote a book called Rare Earth. There it is, if you want to read it. And their whole argument in this book is, why is complex life uncommon in the universe? People, it wasn't 30 years ago that Sagan was saying it's so common there's probably 1 million civilizations in our own galaxy. 30, 35 years later, these fellows are saying complex life may not be anywhere else in the whole universe. And they're daring to say that. Carl Sagan's dead. And I have an idea he knows a whole lot more than he did while he was alive. But these fellows and a host of others are beginning to say, wait a minute. It's a lot of trouble to get life on a planet. Could it be that there's no place else in the universe where complex life exists? That's exactly what they're suggesting. That's why I say to you, class, if you've got professors that are causing your faith to struggle, give it 15 years. And see if they're still saying the same thing they said before. And this is a subject where the subject is completely changed. The Privileged Planet that I mentioned to you a minute ago is a book by Guillermo Gonzalez, who's an astronomer at Iowa State University, and Jay Richards, who's a philosopher. And their thesis in The Privileged Planet, you remember when I quoted to you from Sagan, he said the thought that we're some kind of a privileged place here in the universe is laughable. Think about the pale blue dot. What these guys are arguing is how our place in the universe is designed for discovery. Do you see the word designed in there? The same very rare properties that allow for our existence, that is, as humans, also provide the best overall setting to make discoveries about the world around us. These fellows are arguing the same properties that allow us to be here allow us to have the best optimum place in the universe to observe the universe. Is that an accident? Let me read you what they said. Let me find my place here in just a second. Page 15 of the introduction. Here's what I want to read to you. This is strange because there's no obvious reason to assume that the very same rare properties that allow for our existence would also provide the best overall setting to make discoveries about the world around us. And then they say, we don't think this is merely a coincidence. It cries out for another explanation, an explanation that suggests there's more to the cosmos than we've been willing to entertain or even imagine. What they're saying, folks, is it sure looks designed. And then at the very end of the book, here's what they say. Thus, our inquiry reduces to a single question. Is it possible that this immense symphonic system of atoms, fields, forces, stars, galaxies, and people is the result of a choice, a purpose, an intention, rather than simply some inscrutable outworking of blind necessity or an inexplicable accident? If so, then it's surely possible there could be evidence to suggest such a possibility, and that's what this whole book's about. And then the last section says this. Perhaps we've also been staring past a cosmic signal far more significant than any mere sequence of numbers. He's referring to contact. A signal revealing a universe so skillfully crafted for life and discovery that it seems to whisper of an extraterrestrial intelligence immeasurably more vast, more ancient, and more magnificent than anything we've been willing to expect or imagine. And may I tell you, class, that Guillermo Gonzalez, Dr. Guillermo Gonzalez, a highly respected astronomer, was crucified by 120 faculty members at Iowa State for daring to say such a thing. And to this day, he has not received tenure, though he richly deserves it. The spirit in the scientific community today among colleges, as a general rule, is so anti-creation that if you were to suggest there's an intelligent design, you'd be put in the same category as a medieval monk. Reminds me of the Dark Ages when Roman Catholicism was dominating the world, and it wasn't called dark accidentally. The fact is, ladies and gentlemen, there is abundant evidence now, more than ever, that what they said at the end of that book is absolutely the best understanding. So I want to show you a few things. That's my task. Just want to show you a few things. And starts with this. This is one of my favorite books, God's Crime Scene by J. Warner Wallace. J. Warner Wallace is a cold case detective. Who can tell me what that is? What's a cold case detective? That's a guy that takes an old case that's gotten cold and figures it out. And he is expert at it. He was raised by a daddy who was an atheist and still is. He wrote this book after he himself became a believer, and in the front of it, he dedicates it to his daddy and says, I hope you'll read this, Dad, and become a believer. So he calls the universe God's crime scene, and he uses the powers of investigation that a detective would use to try to investigate it. It's fascinating. Every chapter in this book begins with a murder case and how it was resolved. And then he applies the principles to investigating, is the universe designed or not? So you ready? This is chapter 2. It's called Tampering with the Evidence. Helen knew something was wrong when her daughter Carrie failed to answer the door. It was a bright summer afternoon. Carrie said she'd be home, and her car was indeed parked in the driveway. Helen tried to peek in through the living room window, but the curtains were unusually drawn. Carrie never locked the back door, but when Helen walked into the backyard of the old house, she found the door locked and all the windows closed. That was not like Carrie. She usually left one badly worn rear window slightly ajar. Helen began to panic. She knew Todd and Carrie had a tumultuous marriage, one that included physical violence. Todd had moved out, but Helen still feared for her daughter's safety. The couple had a child named Lexi, but the violence had only intensified since her birth. A week ago, Todd had threatened to kill Carrie, and just last night, Carrie confided there had been yet another fight. When Helen couldn't get Carrie to answer the door on this afternoon, she decided to call the police. Our officers responded and met Helen at Carrie's front porch. After getting approval from the sergeant, they forced entry into the home. Approaching the rear of the house, they began to smell gas. It was strongest at the base of the stairwell, so they backed out. They brought the hazmat team, and they did the things they needed to do to get that gas out of there. And then they went upstairs, and they found Carrie and Lexi dead. And the autopsy showed it was from asphyxiation from the gas. Was this accidental death? Or was it murder? And so the investigation began. And what Mr. Wallace would tell you is, when you start such an investigation, you're looking for foundational evidence first. Evidence that's behind the stuff that's happened. In this case, what do you think that might be? Well, he threatened to kill her. And they had a terrible relationship. That immediately raises questions, doesn't it? Then he looked for regional evidence, the stuff around the house. There were lots of things that were not normal. It just didn't look right. See, the question is, would they have died by gas asphyxiation of something, some mistake they made, or some accident just happened? Or was there tampering from the outside? That's the question. Well, folks, the regional evidence didn't look normal. The door locked, curtains closed, the back door, the back window. None of those were normal. Then he said you look for locational evidence. That's right inside at the scene. The gas thing was open, ladies and gentlemen. And there were clothes stuffed under the door of the bedroom. Harry never did that. I'll tell you the end of the story. Todd was convicted of first-degree murder based on the compilation of foundational, regional, and locational evidence that added up to a case that was unget-overable. So he says the following. We are compelled to examine the evidence of tampering because of an important fact. There were dead bodies in the bedroom. When we look at the nature of our universe, we need to answer the question, where did the living bodies come from? And it should cause us to provoke an investigation. How did living bodies get here? It's one of the most astounding facts in the nature that we are here, folks. Did you think about that? Like our murder scene, there are foundational, regional, and locational conditions demanding explanation. The foundational laws of physics, the regional properties of our solar system, the locational conditions of our planet and of our existence on this planet. Did this have to be the case, the way it is? Did Carrie and Lexi have to die that way? No, there were lots of other things that could have happened. And if small changes had been made, they wouldn't be dead. Folks, the same thing is true with living things on earth. If little tiny changes had been made and many, many different factors, we would not be here. So the question is, how'd that happen? Why is that? I say it's because there's design in the universe. So I want you to look at these quotes. This one from a book called Goldilocks Enigma by Paul Davies. Have any idea why he called it Goldilocks? What do you think, Clay? Well, you can tell me the story of Goldilocks, can't you? Yeah. I'm embarrassing him. I know it's a kid's story, but you probably know it, don't you? Goldilocks went into the woods and found the bear's house, right? And she went inside, and what's the first thing she found? The porridge on the table, right? And so she tried the big bowl, and it was not too much, too hot, right? Help him, kids. And then she tried the mother's bowl, and it was too cold. And then she tried the baby bear's bowl, and it was just right. And then she did the same thing with the chairs and then got on the beds, right? It's all the same thing. It was just, that's why he calls it the Goldilocks enigma. One of the most significant facts, arguably the most significant fact about the universe, is that we are part of it. Everyone agrees that the universe looks as if it was designed for life. It looks as if our universe is spectacularly fine-tuned for life. By this I mean only that it looks as if small changes in this universe's basic features would have made life's evolution impossible. You see what that man believes. But he knows very well that if you changed any of these things, just a teensy bit, we wouldn't be here. Now, ladies and gentlemen of the jury, here's what I'm going to ask you. How many of those possibilities does it take to convince you somebody was messing with this? This just didn't happen by natural causes. How many is it going to take? You'll have to answer that question. What we're talking about here is the Anthropic Principle, ladies and gentlemen. Anthropic, that's the word anthropos, which refers to human beings. The Anthropic Principle, which, by the way, there is zero disagreement about among evolutionists and creationists. We all agree on this one. In the 1960s, there were two characteristics of our cosmos that we found were fine-tuned to make physical life possible, and 8 to 10 characteristics of the solar system that were fine-tuned to make human life possible. When I was in college, that's how many we knew about. By the year 2000 and beyond, we have now discovered 38 characteristics of the cosmos and over 150 of the solar system, all of which are fine-tuned to support life. So, if you had the time, I could give you 188 reasons I believe life was designed. How many does it take for you? Don't believe me, you go look for yourself. Let's talk about a few of them. These are foundational. Like the strong nuclear force and the weak nuclear force and the electromagnetic force and the gravitational force and the ratio of electrons to protons and the mass density of the universe. All of those, ladies and gentlemen, are specific numbers that if you change them one teensy bit, we wouldn't be here. Are you listening to me? Let me tell you how teensy, so you'll get the idea. This is page 52 of his book. If the ratio between the let me go back to this one. If the value of the ratio between electrons to protons deviated by more than 1 in 10 to the 37th, the universe as we know it would not exist. And that didn't mean anything to you. He's saying if you change that ratio by less than 1 in 10 to the 37th, the universe wouldn't be here. And you wouldn't be here. So can I tell you how much 1 to 10 to the 37th is? He gives an illustration. Listen to me. Imagine covering the entire North American continent in dimes and stacking them until they reach the moon. Now imagine stacking just as many dimes again on another billion continents of the same size as North America. If you marked one of those dimes and hid it in the billions of piles you just assembled, the odds of a blindfolded friend picking out the correct dime is approximately 1 out of 10 to the 37th. The same level of precision required in the strong nuclear force and in the ratio of electrons to protons. Did you get that? Is that unlikely? What's about as unlikely as it gets? But that's the truth, and we know it. Evolutionists know it. You change these numbers, any of them, by any teensy little bit, the universe wouldn't be here and certainly living things wouldn't be here. You think this deserves more time? It deserves the next 6 months. But I move on. How about regional factors? Our galaxy is very important, folks. the Milky Way galaxy that we live in. That is no accident, class, that we happen to be there. Let's talk about that a minute. You know about Hubble Telescope. It's taken more wonderful pictures of the universe than ever in our history. If you haven't gone to your website of Hubble and looked at those pictures, you got to go do that. So, lights, please. I want to show you a famous picture from the Hubble Telescope. See all these amazing stars? What you don't know, class, is that those big ones like that and that and that and that and that and that, all the ones that have a glow around them, those are not stars. Those are galaxies. And this is just one section of the universe in the constellation Serpens. A typical galaxy like that one has about 200 billion stars in it. There are lots of galaxies out there in the universe. That's why Sagan would tell you, surely there's lots of civilizations out there. But let me tell you, class, we have learned a whole lot of restrictions. Lights, please. What we've learned is that most of the galaxies in the universe are either elliptical or irregular, neither of which can support life. And everybody knows it because of the features of those galaxies. 95% of all the galaxies are of those types. Then there's a few that we call Seyfert galaxies, and they blow up every so often. A few of them are like ours, a spiral galaxy. Milky Way is a spiral galaxy. Just happens to be the perfect kind of a galaxy to support a living system like we have here in our solar system. Now, you could argue, class, well, that's just a coincidence. It just happened here in one of these places. That's where it can happen, so that's where it did happen. Just a coinkydinky. My question is, how many of those coincidences will it take for you to believe somebody tampered with this? So you have to have the proper type of galaxy, and I can tell you that eliminates almost all the galaxies in the universe. Second, you have to have the proper place in the galaxy. It can't just be anywhere in that spiral galaxy. Here's a sideways picture of that spiral galaxy. The middle of a spiral galaxy is a big old bulb like this. If our sun sat right in there, it would blow up. There's too much gravitational attraction and all kinds of other forces taking place. No. You know where our sun sits? Right about there. There's a bulb right in here and right out here where you can have a solar system like ours sustained, but about 95% of the space of that galaxy is eliminated because it won't support life. You with me? We're narrowing down, aren't we? But you got to have the right kind of star. It's not just any old star, people. Our sun's a special kind of star. Here it is compared to the planets. There's our sun, and here are the planets. But let's take our star compared to some other stars. Here's our sun. There's the Sirius, the dog star. There's Pollux and Arcturus. Our sun's not much compared to Arcturus, right? But watch. Arcturus isn't much either. There's Arcturus compared to Rigel and Aldebaran and Betelgeuse and Antares. Where's the sun up here? Right there. Our sun is an average-sized star. There are lots of dwarf stars smaller than our sun. There's a lot of humongous stars way bigger than our sun. We're about in the middle. Just right. But you got to have the proper mass of your planet. You think any old planet will support life? Let me ask you, class. Where are we looking for life in our planetary system besides here? Mars. Jupiter's way too big, Saturn's way too big, Uranus and Neptune way too big, Earth is just right. What's this one right here? Anybody know? Mars? And that one? Venus? And that one? Mercury? No, this is Mercury. Oh, that's Pluto. Here's Mercury and here's Pluto. By the way, Pluto's back. I have a whole lecture on Pluto if you're interested. Mars. It's in the habitable zone, and it's about the right size. That's why we're looking. Anybody know why we're not looking on Venus? It's also in the habitable zone, but Venus has big problems. It rotates the wrong way. Do you know? Maybe a little too hot. And it also has sulfuric acid in its atmosphere. That's not real good for life, living things. So I'm telling you, you have to have the right size planet, too. But that planet has to be right distance from the sun. It's called a habitable zone. Out of all our planets, Earth is in the perfect, what do you call it? Just right. Now, you could argue, class, if you're my jury, you could say, well, it had to be in that zone, so that's where it is, and it just happened that way. That's where it is, okay? I'm okay with that. I'm asking you, how many times are you going to say that? That it's just another coincidence. It also has to have the right spin and the right tilt. Here's a picture of the tilt. You know our Earth is tilted at 23.5 degrees. You learned this in physical science, everybody. What does this do for our Earth? It creates the seasons, doesn't it? And the dispersion of heat. If that were not the case, there would be no life on this planet. You need to go home and thank God for 23.5 degrees. So is that just chance that that happened that way? Well, maybe that's another one of those coincidences. But that's what had happened here. Not only that, it's got just the right moon. Did you know that? Our moon is perfect, just right, for 68 reasons. There are 2 whole chapters in those books about moon. Pardon me, moon, for my short, inadequate treatment. But our moon is just right. And if it weren't, we wouldn't have life. Then you have to have just the right atmospheric conditions, just the right terrestrial crust, and 140 more different characteristics that all have a very small limit of variation, which I don't have time to tell you about the other 140. But you can go look them up. And then there's water. If you were in my chemistry class, ladies and gentlemen, we study water more than any other subject, any other one substance. It's the most fascinating substance there is. It is unique. It covers more than 70% of the Earth's surface. What are they trying to find on Mars? Evidence of water. Because everybody knows no water, no what? Life. Period. From 70% of the surface of the Earth, what do you have on Mars? They're having trouble finding any. Most plants and animals contain more than 60% water by volume. So, girls, if you call each other waterheads, you are right. I hope you don't call each other that. But you're right. You know what percentage watermelon is of water? 98%. Boy, it sure tastes good though, doesn't it? It has a unique structure. Everybody knows it's H2O, but did you know that it's 2 H's combined to the oxygen at 104.5 degrees bond angle? And if it weren't that bond angle, it would not have all these amazing properties of a polar molecule that gives it all these things it can do. It's incredible. So you can believe if you want to, that was just one of those accidents of nature that was brought about by some mysterious force, or you can believe it was designed like I do. It's the only substance on Earth that exists in all 3 states, solid, liquid, and gas. It has the uniquely high specific heat. Look, if you want to stay about the same temperature year-round, come to my town, Tampa and St. Pete, Florida. we're surrounded by water. It takes a lot of heat to raise the temperature of water and a lot of heat to lower the temperature removed, because it has such a high specific heat. It's amazing. If you take every other commonly occurring substance on earth, it's around in here, and then boom, there's water. It's specific heat. And that's the truth for many, many properties. It has a wide temperature range for liquid, and you better be thankful about that. In your bloodstream, it's mostly water. It regulates your temperature. And it dissolves about everything. Most reactions in your body take place in water solution. Did you know, class, that liquid water is more dense than solid water? That's not supposed to happen. When things solidify, they get more dense, don't they? Did you drink tea tonight? Where was your ice? Was it sitting on the bottom? No, it was floating on the top. Solid water is less dense than liquid water. Did you know, class, if that weren't the case, you would not be here? That's the truth. It's the universal solvent. It has high surface tension and cohesion. How do you think water gets from the roots of a tree 50 feet up? Because of the properties of water. Everywhere we look, class, from the macroscopic to the microscopic, things look like they're made. And I want to tell you, the Anthropic Principle is a loud, piercing cry of design. 188 different features that all have to be carefully fine-tuned for life to exist. Why do you think Ward and Brownlee are now saying there may not be another place in the entire universe where there's complex life? They still believe it evolved, which is utterly ridiculous, based on what we talked about Monday night and a whole lot of other things. Michael Behe said it well. There's a loud, clear, piercing cry of design everywhere you look. I've said to you a couple of times, I'm leaving a bibliography with Bruce of all the books I've used, and I've put stars and sometimes 3 and 4 stars by the very best ones. If you want to dig in, you got lots of fun ahead of you, because there's so much good material now that supports your belief that there's somebody that tampered with this. This did not happen by natural causes. This was designed intentionally. And the evidence supporting it is overwhelming. I hope you enjoyed that. So is it reasonable to believe in God in this scientific age? My answer is it's more reasonable than it's ever been. And one of these days, when we come to the judgment scene, God's going to say to us, anybody that doesn't believe in Him, what did I have to do for you to help you believe? So I love to tie John 14, verse 6 to this out of the Bible, because you know in that passage, Jesus is talking just before He's crucified, and He says to His disciples, believe in God, believe also in me. In my Father's house are many mansions, and I'm preparing them for you. And then He said, I am the way, the truth, and the life. No one comes to the Father by me. So the message of Scripture, way beyond what nature can teach you, is that God so loved the world that He gave His only begotten Son, that whoever believes in Him should not perish, but have everlasting. And that we would wish for you as well as for ourselves. Don't you want to spend eternity with a God that could do what He's done in creating you and everything else? My, I do. I don't want to miss that. And Jesus said, believe and be baptized, and you will be saved. So we're going to sing a song. If you want to respond in any way to the gospel call, come while we stand.